Yeah.
That's okay.
Okay.
The microphone is on. Yeah.
Good evening, everyone. For those of you who don't know me, my name is Doug Baxter. I'm the current president of the Pleasant Lake Protective Association. And I just thought I'd have some few opening remarks and thank you all for attending. Many of you were in this same room 2 years ago, or I guess about 1 year ago, for a presentation for one of Dr. Baer's classes that had done quite a bit of work on Pleasant Lake on the watershed and starting with the tributaries. However, those sampling dates were in the late fall and early spring, and we realized that we were missing some critical data from the latter part of the spring and the summer when we have heavy rains, gully washers, and lots of runoff that could potentially impact the lake, algae blooms, etc. So the Lake Association, in conjunction with Dr. Baer and Dr. Lutz, had some discussions about basically hiring 3 students to do some more extensive sampling throughout those months that we had missed. And tonight is basically the culmination of that, the report. And I'm not going to talk anymore and steal any of their thunder, but I'd like to thank both Samantha Karras and Quinn Aldrich for the hard work they've done. And I think you'll be pleased with what you see. Thank you.
Hello, everyone. Welcome to our presentation of our summer watershed analysis of Pleasant Lake. So as Doug said, this continued and built upon the sampling efforts of last year's community-based project class. And Sam and I will be giving this talk on behalf of our team, which also includes Stephen Williamson, Nick Baer, and David Lutz. We'd like to thank the PLPA for funding this project over the summer, and we are excited to share with you our results from the summer, year-long trends, and our conclusions.
Yes. It's not in days. I got you.
Okay, so we wanted to introduce a little bit about us since we've been collaborating with you all for a year and wanted to share our backgrounds. So my name is Quinn Aldrich, and I'm a senior environmental science and chemistry minor, environmental science major and chemistry minor here at Colby Sawyer. I grew up in New Hampshire, and I've always loved lakes and being on the lake in my kayak, as you can see in that middle picture there. I interned at the Department of Environmental Services for 2 summers in their cyanobacteria program, and that really sparked my love for water quality and freshwater biology. So I've collected cyanobacteria samples from all over the state, and that really influenced my interest in Pleasant Lake, seeing an oligotrophic lake have cyanobacteria blooms for 3 years in a row. This project on Pleasant Lake has been a great experience that has allowed me to bring my passion for environmental science and chemistry to a year-long project.
Hi, I'm Sam Karras. I'm a senior environmental science major and biology minor. So I grew up in Maine, but while Quinn was working with DES, I had a very different summer in Wyoming working for the U.S. Forest Service. I interacted with the public daily, and it really showed me how the community cares about preserving natural spaces that they feel connected to. And I saw the same passion throughout the Pleasant Lake project, and how much you guys care about the environment. So during the 3rd year project, which was really my introduction to this, I loved working in the field and gaining experience in the lab. And we really want to thank you for the opportunity to continue this research over the summer. It was really rewarding to see the project through and allowed us to develop really valuable skills to take onto us in the future. So while many of you were here during last year's presentation, I'm going to briefly summarize our key findings as they really help shape the direction of our future research, or our summer research. So our primary focus was to begin building a comprehensive data set to identify trends and highlight areas of concern within the watershed. During the school year, a team of 10 of us sampled base flow sites every week with additional sampling during storm events. Between September and April, we collected samples 22 times, which was a total of 750 water samples. This data set provided really valuable insight into seasonal changes within the lake, particularly the significance of spring phosphorus flushes driven by precipitation and snowmelt. We also identified several key sites and areas of concern, both in terms of concentration and loading of nutrients and contaminants. Among these, chloride and phosphorus emerged as our primary focus due to their significant impact on water quality within the watershed. Change slides. So we found that storms and snowmelt played a critical role in water quality within the watershed. We saw that as increased precipitation and snowmelt led to higher total discharge or the volume of water flowing into the tributaries. We saw that with this increase of water volume, there was a resulting of total loading of chloride and phosphorus into the watershed. There was also a higher potential for phosphorus entering the lake with these flushes, as rain events and snowmelt tend to stir up sediments, nutrients, and organic matter, leading to pulses of phosphorus-rich runoff entering the tributaries. We observed this in our data throughout this due to increased turbidity during storm sampling. However, while chloride loading increased with higher water volumes, its concentration tended to be diluted and decreased. Change slides. While storm events increase phosphorus and chloride loading within the watershed, we also aim to understand the differences in nutrient dynamics and concentrations between different sites. Then we started to examine historical septic use and land use patterns to understand differences in concentration. So using the town septic records, we did not find a significant correlation between outdated septic systems and elevated phosphorus concentrations. We then began to shift our focus into a broader land use practices. As seen on this map here, we digitized land use that quantified a couple things. The first being the level of development within the watershed, the extent of impervious surfaces such as roads and buildings, which all contribute to nutrient runoff. Finally, we looked at road salting practices. So these maps showed us a lot about the watershed. They allowed us to draw connections between land use and water quality, and our analysis revealed a few relationships. We saw that the percent of impervious surfaces and phosphorus concentrations were related, and the percentage of housing cover and phosphorus concentrations were related. These findings provided important insights to how human development influenced nutrient loading within the watershed, which we continue to explore into the summer. Slides. Mentioned this earlier, but this shows all of the town and state roads as well as private driveways within the watershed, and we saw that the higher salt application between these roads led to higher chloride concentration. So we use the same approach to assess the impact of road salt application on increasing chloride concentrations within the watershed. So we used a similar approach, digitizing and quantifying roads within the watershed, distinguishing between town roads and state roads as they differ in salting practices. Our analysis confirmed that increasing salt application led to rising chloride concentrations. We also identified a few key sites that were particularly impacted by significant road salt applications, primarily through state-maintained roads. Additionally, one notable site, Site 26, located at the intersection of Elkins and Bunker Road, was heavily influenced by development and road salt application, making it a key site that we continue to monitor into the summer. So building on last year's findings, we set our objectives for the summer research. So sampling during the summer allowed us to understand the timing of cyanobacteria blooms and phosphorus inputs during the year, sampling during times where these blooms actually occur and not just during the winter. Since snowmelt was such a key driver of water quality in previous years, we shifted our focus into capturing summer storm events to analyze their impact. Our analysis centered on three main objectives, the first being comparing tributary data with 2024 VLAP data to assess seasonal differences and evaluate nutrient and contaminant loading across the seasons. Finally, we wanted to identify factors influencing variations in nutrient concentrations. So looking at how many total samples we collected, with our biweekly sampling and storm event samplings, we collected a total of 504 water samples, resulting in over 3,000 individual data points. We collected a total of 99 storm samples, which added to 750 additional samples that we collected throughout the year. Next slide. So we sampled looking at our methods and additional contributions for summer efforts. We sampled our baseflow sites twice per week, measuring water discharge in the field and looking at key parameters in the LSPA lab. We also tested phosphorus concentration of each sample every week. We also added additional sampling during storms and precipitation events. This process evolved over time as we got a better understanding of when nutrient flushing occurs. We collected samples during peak precipitation as well as before and after nutrient loading from storms. We saw that there was a significant decrease in the number of flowing sites throughout the summer, so we added a few additional methods to compensate for this. On August 19th, we conducted an E. coli sampling of our baseflow sites. While these results did not indicate elevated levels, this test could serve as a potential future monitoring tool to identify faulty septic systems in the future. We also focused on coordinating our tributary sampling with the Volunteer Lake Assessment Program, or VLAP sampling, to conduct a paired analysis. Finally, we collected an in-lake sediment core at our VLAP sampling sites. After identifying the key sites with significant discharge in nutrient concentrations, we expanded our analysis to explore nutrient loading sources. This led us to implement a new method, headwater sampling. Headwater sampling provided us valuable insight into how phosphorus concentrations at upstream locations compared to those at our regular tributary samplings. We use GIS mapping and subwatershed delineation to identify the headwaters of our key tributary for targeted analysis. We combined this information with our field exploration of the streams and identified a headwater site location. While this was often a muddy process, as you can see, this approach helped us to understand how water quality changed as it reached Pleasant Lake. Next slide. So looking first at phosphorus concentration at our headwater sites versus normal sampling locations, the box plot here shows that the concentrations at headwater sites in green and tributary sampling in blue in micrograms per liter. Overall, phosphorus concentrations at headwater sites were often equal or higher at tributary sites. In particular, Site 4, White Brook and Little Brook had significantly higher phosphorus levels at their headwaters compared to their downstream tributary sites. So one likely explanation for these elevated levels is the proximity to wetlands near these headwaters. Wetlands are naturally rich in organic matter and serve as phosphorus reservoirs. As water flows downstream and mixes with other tributary waters, these concentrations typically dilute. However, at Site 26, the opposite trend emerged. Phosphorus concentrations were higher at the tributary samples than at the headwaters. This is likely due to downstream inputs from developed areas where runoff from impervious surfaces introduce additional phosphorus. Next slide. Next, looking at chloride, a similar pattern was observed with the concentrations. Headwater samples from White Brook and Little Brook displayed higher levels compared to their tributary counterparts. However, Site 26 and the Fire Pond had significantly higher concentrations of chloride at the normal sites. So looking at a map of these sites, overall, headwater sites exhibit higher phosphorus or consistent phosphorus and chloride concentrations compared to other tributaries. This indicates that concentrations were diluted before entering the lake. However, Site 26 again stood out, with tributaries sampled showing elevated phosphorus and chloride levels. A headwater sample was taken at the Esther Currier Wildlife Management areas, which had showed significant lower concentrations of phosphorus and chloride. This suggests that as water moves closer to the lake, it's impacted by external factors such as road salt application from nearby states and roads, and impacted by developing areas. We also continue to examine the impact of human activity within the watershed on phosphorus concentrations. Our updated land use maps and summer data provided further insight into these relationships. This map shows here all of the housing within the watershed and its corresponding average phosphorus concentration of each watershed, which informs our next analysis on the next slide. We continue to examine the impact of human impact on water within the watershed on phosphorus concentrations. Our updated land use maps and summer data provided insight to this. We saw that there was a significant positive relationship between housing coverage and total phosphorus concentration with a p-value of 0.006. This indicates that area with higher percentages of housing coverages are correlated with elevated phosphorus levels. However, our model only explains about 4.5% of the variability in phosphorus concentration, highlighting the presence of other factors influencing phosphorus concentration. The watershed remains relatively undeveloped, with housing coverage comprising less than 2% of the area. Thus, we wouldn't expect housing coverage to be a primary driver of phosphorus concentrations. However, our findings do suggest that human activity and impervious surfaces still play a role in phosphorus levels within the watershed. With this information, we'll want to continue to put efforts towards preserving the watershed, which clearly is something that this community cares about. Next, I'm going to turn it over to Quinn, who's going to discuss our data in comparison to VLAP data and the impact of storm events and key sites for management.
Yeah, go ahead. Go get the other, let me get the other one.
Okay, let me turn it on from then on.
Point it to this, point it to this. Yeah, no,
I'm just gonna point at you every
that's
time
fine, that's
I
fine.
read
Here,
it,
point away.
so you know.
That's fine.
Okay. Oh, the other way. What? Oh,
I think it's,
down. There we go. Okay, great.
Just the first one of that map.
Okay.
you're fine.
So another analysis we focused on this summer was comparing the in-lake VLAP sampling measurements to our tributary data. So as Sam mentioned earlier, VLAP is the state's volunteer lake assessment program and has conducted summer lake sampling over the state with the help of local volunteers for decades. We did this analysis by sampling the tributaries on the same days as VLAP sampling, so we could conduct a paired analysis between the two to see if there was a significant difference. VLAP and our sampling sites were June 11th, July 9th, and August 13th, and were all considered base flow sites. Sites in this analysis included the outlet, the tributary by Peter Winship's house, Great Brook, Slope and Shore, White Brook, Red Brook, Site 23 on Bunker Road, and the fire pond by Elkins Beach. This analysis aimed to determine whether tributary sampling produces more meaningful data than in-lake sampling at the inlets, as well as visualize the variability between tributary measurements. So you're gonna have to click through a lot. I had little boats pop up to show you the different sites.
Oh, I'm sorry.
No, it's okay. It was too many points.
You can just, just tap your finger when you want me to move.
All right, so this graph shows conductivity levels at the VLAP versus tributary sites, with VLAP sites represented in the blue bars and the tributary sites in green. In lakes, a conductivity level of above 100 microsiemens per centimeter is a red flag for water quality and indicates human influence. For reference, the average conductivity from the VLAP samples taken this summer was found to be 47 microsiemens per centimeter, which is well below 100. One may see these values, and as there is little variation between in-lake sites as well as between days, one could infer that the conductivity inputs are low and stable throughout the watershed. However, looking at the tributary sites in green, we can see there is greater variation within the sites, as well as between days. For the dates sampled over the summer in this analysis, slope and shore had average conductivity of 137 microsiemens per centimeter. We can see that this value is well over 100, and it's not the only one. White Brook had an average conductivity of 141 microsiemens per centimeter in the tributary samples, as well as high variability due to weather and flow conditions. Red Brook had the highest conductivity of the tributary samples, with an average of 193 microsiemens per centimeter. However, not all the tributary sites had higher values than the in-lake VLAP sites. We can see that Great Brook and Site 4 had lower conductivity values in the tributary sites than what was seen in lake. In terms of significant differences, only Red Brook and the Fire Pond had statistically significant differences between tributary and in-lake samples. However, in this paired analysis, we only had a sample size of 3 for each site, making it difficult to conclude with high confidence. However, the variability of conductivity between sites is apparent and is a valuable indicator of sites that contribute water of higher or lower conductivity into the lake. Next slide. Okay. We also analyzed the difference between phosphorus concentrations at VLAP sites versus tributary sites, since phosphorus is a driving nutrient in accelerated eutrophication and cyanobacteria blooms. Similar to the trend we saw in conductivity values, phosphorus levels in lake at each of the inlets remained relatively stable throughout the summer, with the sites having average concentrations of less than 0.008 milligrams per liter. Having only this data available, it would indicate that phosphorus inputs into the lake are relatively low and stable and consistent across the watershed. However, once sampling the tributaries, we see that this is not the case. Red Brook had the highest average phosphorus concentration of the tributary samples, with a concentration of 0.045 milligrams per liter, and this is almost 6 times higher than the average levels at the inlet site would lead one to believe. The Fire Pond also yielded a high average phosphorus concentration of 0.04 milligrams per liter, which is 5 times higher than VLAP levels indicate. So to put these values into perspective, lakes can be classified based on their biological productivity, but also phosphorus levels. An oligotrophic lake, which Pleasant Lake currently is, has phosphorus levels of less than 0.008 milligrams per liter. Looking solely at the VLAP data, one could conclude that phosphorus inputs from around the lake are relatively low and within the limits of an oligotrophic lake. However, looking at the tributary data we collected over the summer, you can see that the phosphorus inputs range anywhere from 0.1 to 0.45 milligrams per liter. Some of these levels even exceed the phosphorus limits for a hypoeutrophic lake. In terms of significance, we only see statistically significant differences at sites 4 and 27. However, as with the last analysis, the sample size of 3 makes it difficult to conclude this with high confidence. Despite this, the variability in the tributary data is apparent and illustrates that it is a meaningful reading and indicator of inputs into the system rather than mixed and lake samples. Another focus we had for the summer was quantifying the impact of summer thunderstorms and heavy precipitation events on phosphorus concentrations and loading. On June 20th, the day after Pleasant Lake saw its first cyanobacteria bloom of the summer, our group sampled in the morning for a regular base flow sample. Little did we know, around 6 p.m. there would be a thunderstorm with heavy rains dropping around 0.4 inches in 1 hour. Sam and I knew we had to go out and sample this storm to see the impacts, especially since it hadn't rained in a while and it was likely to flush sediment and nutrients into the system. The data we collected that day is on the chart, with phosphorus concentrations in micrograms per liter displayed before and after the storm. We saw dramatic differences in phosphorus concentrations. Prior to the storm, Great Brook had a concentration of 30 micrograms per liter, and it increased to 91 micrograms per liter, so it was 3 times as high. Little Brook saw the most significant increase, going from 13 micrograms per liter before to 123 after. This is almost 10 times as high. The trend was the same for the sites that also typically see higher concentrations, as the site at the corner of Elkins and Bunker Road increased from 45 micrograms per liter to 168. Lastly, the fire pond yielded the highest values, increasing from 83 micrograms per liter to 198. To loop these values back to the classifications of lakes, an oligotrophic lake has in-lake phosphorus levels of less than 8 micrograms per liter. After the impact of the storm, the fire pond is bringing in water with a phosphorus concentration of 198 micrograms per liter for a period of time. Although we know that concentration only provides half of the story, so we wanted to calculate loading on this event to truly quantify the impact of these summer storms. We saw that storm events drove summer phosphorus loading across sites and wanted to illustrate this trend using the fire pond pre- and post-storm, as well as Little Brook. We know that storm events not only increase discharge or the volume of water entering the lake over a period of time, but also turbidity, or the sediments and sediment-bound phosphorus being washed into the water. Using phosphorus concentrations and discharge measurements, we were able to calculate the grams of phosphorus entering the lake in 1 hour versus 1 day. For the fire pond during a storm event, it would bring in about 211 grams of phosphorus into the lake in 1 hour. During base flow, the fire pond would bring in about half that amount of phosphorus in an entire day.
Am I off?
There we go.
Thanks, sorry.
No, you're good. So during a 1 hour storm would bring in almost twice as much phosphorus as a day of base flow for the fire pond. So that shows how impactful these storm events are. Now the fire pond is one of the highest sites in terms of phosphorus concentration that we have. So we wanted to show the impact of that by comparing it to Little Brook, which is a site with consistently lower phosphorus, but brings in a similar volume of water. Using baseflow discharge and phosphorus measurements, we calculated that Little Brook brings in around 1.92 grams of phosphorus each day. This means that the fire pond brings in as much phosphorus in a 1 hour storm as Little Brook would bring in 110 baseflow days. After seeing the dramatic impact of storm events on particular sites, we wanted to see how our biggest contributors varied seasonally. Phosphorus loading is a key measurement to focus on in terms of management efforts, as it indicates the amount of phosphorus entering the system from the watershed and from where. This graph displays average phosphorus loading using data from the year-long study showing sites that contribute the most phosphorus into the system. You can see that the greatest contributor is Great Brook, which consistently brings in water of low concentrations, but brings in a large volume of water. The subwatersheds of Great Brook and Little Brook, which ultimately flows into Great Brook, are almost entirely undeveloped and forested landscapes. So it's likely that the phosphorus from these sites is from natural sources, such as leaf litter, and not human influenced. The second highest contributor is the fire pond, which has had consistently high phosphorus concentrations throughout the whole year, as well as brings in large volumes of water into the system. Its subwatershed is moderately developed and part of Route 11 runs through it. The next two sites of concern are Red and White Brook, whose subwatersheds have high percentages of human development and impervious surfaces, such as Main Street and Route 114. Looking at the influence of seasonality within these sites is important in understanding spikes in nutrient loading and flushing and how best to implement management practices. When analyzing the seasonal impacts of phosphorus loading, we see that spring has significantly higher phosphorus loading across our key sites than fall and summer. We can also see that summer is consistently the time of lowest phosphorus loading. However, this value is likely an underestimate as there are many summer storms that we were not able to sample and that are significant sources of phosphorus loading. Nonetheless, this graph illustrates the importance of sampling during months other than summer to better understand nutrient loading within the watershed. Lastly, we wanted to analyze the seasonal impact of chloride concentrations. As throughout the academic year, we found data to support that sites with state-maintained roads within their subwatersheds were significantly impacted by the increase of road salt application rates at the state. There's scientific literature that suggests elevated chloride levels can negatively impact zooplankton, which feed on cyanobacteria. Due to salt application occurring in the winter months, we expected to see these concentrations peak in the spring, but this was not the case. This graph shows our 4 sites with state roads in their subwatersheds and the chloride levels in each season. We see that summer concentrations are comparable, if not greater than spring chloride. Particularly Site 26 at the intersection of Elkins and Bunker Road saw its highest chloride concentrations in the summer, sometimes upward of 200 milligrams per liter. These trends support literature that has found that chloride ions from road salt application do not immediately flush into water bodies and are stored in the soil and slowly leach out throughout the year. These seasonal differences are important in understanding how chloride is entering the lake and impacting the organisms. Concentrations like those seen in Site 26 could be lethal to zooplankton, especially in the area where the inflow enters the lake. Future management plans for key sites, as well as continuing monitoring, is important in protecting the quality of Pleasant Lake. In conclusion, we found that Site 26 at Bunker and Elkins had higher phosphorus and chloride concentrations where it enters the lake than at its headwaters, which indicates that there's an input of nutrients and salt along the stream as it approaches the lake. The same trend was seen in the fire pond with chloride. Future bracket sampling up these streams to pinpoint the location of the spike concentration could be done. These sites will also be of high importance for future monitoring efforts. We found that percentage of housing cover significantly correlated with phosphorus concentrations, but it was not the only factor. We found that sampling the tributaries provides different and more variable results than in-lake sampling at the inlets. Tributaries are a relevant indicator for quantifying the nutrients entering the lake. We found that summer storm events increase phosphorus concentrations and drive summer phosphorus loading. And this is very important in understanding cyanobacteria blooms. We found that phosphorus loading was highest in the spring, flushing the most nutrients into the system. And lastly, we found that chloride stays in the soil after it is applied in the winter and slowly leaches out into the water throughout the year, potentially impacting zooplankton. So potential next steps that the LSPA or the PLPA can take are changing future VLAP sampling to include tributary samples in addition to their in-lake sampling. Tributary measurements provide accurate data of the quality of water entering the lake. Measuring dissolved oxygen and temperature levels below 25 meters at the deep spot will also give a better indication of potentially anoxic conditions, which can cause sediment-bound phosphorus to become labile. Analysis of the sediment cores that we took during the summer could be a potential way to analyze how much phosphorus is located in the sediment. Future E. coli testing in tributaries could be a method to implement to determine whether there is an influence of faulty septic systems into the tributaries. Working towards a salt minimization plan for the state roads within the watershed boundaries would help reduce the input of chloride into the lake from the high winter road salt application. And the data collected over this year-long study can be used for a future watershed-based management plan if the PLPA wishes to secure funds from the state. So what can homeowners do in the Pleasant Lake watershed, whether you're located directly on the shoreline or anywhere throughout the watershed? So discontinuing or limiting fertilizer use, whether it's synthetic or organic, will make a difference. They all contain nutrients. In addition, discontinuing or limiting winter road salt use or opting for chloride-free alternatives would be an important way to help. Maintaining your septic system is a way to make sure that it's functioning properly and not contaminating the lake or groundwater. Implementing shoreline buffers as well as native vegetation on your property is a good way to improve infiltration and decrease runoff. Lastly, a good way to get involved is to volunteer, and I'm going to talk about a couple examples of projects that have been completed at the nearby Lake Sunapee for their watershed management plan. So with the help of a group of volunteers, a rain garden was put in at Buckland Beach on Little Lake Sunapee to slow runoff and allow plant uptake of nutrients. Previously, the rainwater would run off the road, down the beach, and directly into the lake, likely washing in sediments, nutrients, and chloride with it. The project looks great, is good for the lake, and is something that the Pleasant Lake community could implement in a future management plan at any beaches along the shoreline. Next, the Grand Lead-In project was completed, where gravel pits, swales, and concrete catchment basins were implemented to slow down water and allow particles to settle before entering the lake. This project required larger equipment and engineering than the rain garden, but works as an effective way to reduce nutrient and sediment loading in an area where stormwater runoff was an issue. Something similar could be implemented in the Pleasant Lake watershed where water runs along the road. And thank you, and we'll now take any questions and feedback.
Sam, could you talk a little bit more about dissolved oxygen? I had a very brief chat with Craig earlier tonight. And but I'd like to know more about why that's important. Why do you need to know about dissolved oxygen?
The dissolved oxygen at the deep spot of the lake. Yeah, so when dissolved oxygen gets really low at the deep spot of the lake, the phosphorus likes to bind to sediment. So it like causes the phosphorus that's bound to the sediment, the chemical reaction, the what is it? The equilibrium reaction pushes the other way. So it actually becomes soluble in the water. Whereas if the oxygen levels were higher, it remains bound into the sediment. Yes.
Couple of your graphs for white and red brook showed higher concentrations when found chloride and other phosphorus. Spring Ledge Farms is upgrade from there. Do you see any correlation between fertilization practices of Spring Ledge and the impact on white and red brooks?
So we didn't look into their fertilization practices, at least at the Spring Ledge that is in the watershed of White and Red Brook. We did do sampling along the stream where the strawberry farm is, right near the lake, and we didn't see any significant differences upstream or downstream in terms of phosphorus and chloride there. But yeah, we didn't do any bracket sampling of White and Red Brook and to see that, but that would be something that would be interesting to look at.
If I could just add, Bill, that's one of the things that our watershed committee wants to take all of this data, raw data, and start doing what you just mentioned. Let's go upstream and start looking a little further. What are we finding we could be influencing this? That's our job. That was not asked for Sam Bunker and Elkins Road, but yeah, I think we've got a lot of work to do using the information that we're getting from this.
So you guys are now the most experienced scientists in terms of collecting water in Pleasant Lake and the tributaries. And what would you suggest in terms of cost-effective sampling? It's always limited resources financially. What would you suggest in terms of the number of tributaries that you'd sample? And which ones would those be? Obviously the ones with red flags. But would you suggest sampling any of the other tributaries as well?
I think the ones with highest concentrations and the highest loading, so the Fire Pond and Great Brook, 100%. And then Site 26, even though it had lower discharge, it had far more or higher levels of concentration of chloride and phosphorus. Focusing on that.
And just to add to that, yeah, definitely like those sites that are like flowing the most, because as if you guys came to our previous presentation, we had up to like 60 sites in the winter that were flowing. But doing our analysis, we saw that like, some of the tiny sites don't really make the biggest impact, and you can definitely have smarter sampling practices that won't take as much time, use as much resources. So definitely focusing on those sites of concern, like Sam said.
And it sounds like the volunteers need to wear their raincoats
Yeah.
and go out after storms. You guys hear that?
Yes.
Yeah.
So, just so we understand, the cyanobacteria blooms, which unfortunately seem to be pretty consistent in Pleasant Lake, almost predictably, like, the end of June, middle of June. What role does the phosphorus play versus the the calcium play on the cyanobacteria. I don't know what the chemical reaction is, but what I'm trying to say is you've tracked phosphorus, you've tracked obviously the salt content. So I don't fully understand what respective role each of them play in the blooms. And I know that the town is going to implement some kind of monitoring of septic tanks around the lake. That I think that is an ordinance that move forward, but if you have any suggestions on how we could more effectively control the phosphorus beyond just the sampling. And I know you've mentioned a few things in terms of barriers between the road and the lake. But at this juncture, we're kind of far down the road on the phosphorus. So is there any kind of intervention that would have more dramatic and immediate effect? I know that's a long question.
Right. So to address the first part of the question, in lakes, phosphorus is the limiting nutrient, but also in addition, cyanobacteria are able to fix nitrogen. So to grow, phytoplankton need nitrogen and phosphorus. But cyanobacteria can fix nitrogen from the atmosphere, so they actually don't rely on nitrogen inputs to grow. So whenever phosphorus comes into the system, they're able to grow like crazy and outcompete other phytoplankton. And that's why we see these cyanobacteria blooms that can potentially produce harmful toxins. And that's why we're so concerned about them. So yeah, analyzing for phosphorus instead of nitrogen is kind of the way to go with that. And then I'd say in terms of other management practices that you can implement, I know I just gave a couple examples from the Lake Sunapee Watershed Management Plan, but they have other areas that they've worked on as well, further away from shoreline. That would be really cool to look into, and that's all online. And yeah, they have some great examples.
You did
Yes.
sampling for E. coli one time, but suggested that might be something that could deserve follow-up. Is
Well-
there a recommendation for how that would be done?
I think it was honestly an experiment to see if it could be used as a method in case there was a hypothesis that there was a leaking septic system. We didn't find any concern. I think it would be more if a concern. Yeah.
Also, just to add really quick, so the E. coli, like it is a way, but it's also difficult. Like, how are you going to tell whether it's human influence or just natural? But there are a lot of recent studies that have been looking at like caffeine or like artificial sweeteners in water, which is interesting. It's probably also expensive, but that's kind of a way that people have been trying to pinpoint whether it is human influence, because with E. coli, you never know what it could be. So yeah. You in the back.
Is the flow into the fire pond, is that coming from across Route 11 from the low plains area? And
Yes, yeah.
Could some of the beaver activity over there be causing some of the issues, and is there anything that could be done with that?
It could be. It's also the concern is that it's sitting in the fire pond, like collecting organic matter. So probably is both of those.
I'd like to follow up on that question earlier. I think that Greg does a good job of Spring Ledge, and I think he would be aware of and very sensitive to his agricultural practices and the impact on the watershed. I didn't want to,
Yeah, absolutely.
On the fire area where a lot of those chemicals are coming into the water, how far, it's close to the swimming area where there's activity during the summertime. How far out into the lake does that go? Does it dissipate over time, or does that end up settling on the bottom?
I'm not exactly sure. I believe once the water comes in, like it mixes into the lake, but I'm not sure how much settles or how much stays. Yeah, I don't really have, sorry, I don't have the knowledge for that.
Can I just add,
Yeah.
one thing that Sam didn't mention is we do have sediment samples that have not been analyzed yet. There's a student, Bailey Tremblay, who's doing this as part of her capstone project. And we're actually taking more samples.
This might mess them up.
Drill through the ice, take some samples of a couple of these spots. But really curious to see what the sediment samples down there where the boats are anchored right there by the fire pond, what they look like. There was another part of that question I was going to speak to, and now I forgot.
We could have a polar plunge.
Yeah. Actually, Doug Benton and I were talking about, we might try to do measurement of dissolved oxygen. With those holes that we drilled this weekend. Maybe some other sampling, while we've got that opportunity to do some winter sampling.
This would be a good time of year to do that as well. In the oxygen, like,
I find it interesting you call it the fire pond. I grew up in Elkins, attending the one-room school, 8 grades. In the 40s, it was a fish rearing pond. You perhaps know that. There was lights just strung low over the just low over the water. And so the bugs would come and the fish would jump up and eat the bugs, and it was just full of fish. Would it help to put fish back in the rearing pool and stop calling it the fire?
That's interesting. I don't know.
I was just gonna, there are questions from here. I don't have an answer about the fish in the fire pond. It's a good question.
All through the 40s and early 50s for sure, and I'm sure it predated the 40s.
into the 60s at least as well.
Is that?
Chandler Brook Rearing Pool.
Has that been court? Do you know how much?
We'll have to rename it.
You know, I suspect it's bringing in a lot of phosphorus
Mhm.
and nitrogen. And there might be quite a bit in the bottom of the pool there that could be contributing.
Okay,
And I think there are also 2 little cottages right on the rearing pool.
yeah.
So there are a lot of possibilities that, and that's the kind of, this is the importance of the study, is it suggests that this is a hotspot that's worth looking at. And a lot of possibilities and requires more research. Any more students you have? Hank?
We have students.
Compared to the cyanobacteria blooms, do you have, how many there were and where they were all located?
I believe this past summer there were 2, and the second one was like very brief, because we actually brought the samples down to the state for them to be analyzed in their lab there. And they were both located near like Elkins Beach in the boat launch kind of area. Whether that's due to the input of nutrients in that area from a particular tributary or wind action, wave action, we don't know. And I believe it was also seen on Lamson Lane. Yeah.
There are a couple questions from the chat, if I can read them. I'm curious to hear your thoughts on some of the catch basins mitigation options and if and where around Pleasant Lake you would consider.
I would think on Lakeshore Drive between, I don't know how to describe this, between like sites 2 and 3 where we would know them. There's an area where I remember after heavy precipitation, the water would just flow right down the side of the road and you could see that it was like eroding. So I think that would be an interesting place to consider, at least kind of that catchment basin, gravel kind of settling option. But yeah, anything.
I was thinking maybe 26, but I'm not really sure.
Oh, yeah.
Near the intersection of Elkins and Bunker.
Yeah.
Another question that came up was cyanobacteria blooms are a visible sign of nutrient overloading. what can we do to minimize the likelihood of cyanobacteria blooms? You may have addressed this already, so.
Continue doing what you're doing in terms of avoiding fertilizers, and your land use practices, pumping your septic system or individual things you can do. And then I think the PLPA is looking towards actions you can do on a more scale. Yeah, the watershed.
A final question from the chat was, could you repeat how chloride affects cyanobacteria?
So chloride levels that are very high can impact zooplankton, which so in the water there is zooplankton and phytoplankton, so in the food web in freshwater bodies. And so when the chloride levels are high, it can be lethal to the zooplankton, and the zooplankton feed on phytoplankton, and cyanobacteria are phytoplankton. So it's basically kind of getting rid of their predator, and then it could allow them to grow out of control even more.
Did you sample for other chemicals besides phosphorus and chloride, and if so, what?
Yeah, so phosphorus and chloride were kind of our main ones that emerged to look at, but we also every sample that we took, we analyzed for color, turbidity, conductivity, pH. Yeah.
Thanks.
You was talked about chloride being held in the soil. Chloride. Being held.
Yeah.
Is that a good thing versus it being flushed into the lake instead of being held? Which would, I mean, I know that's the way it is, and it's an interesting fact to me. Is that good?
I'm not exactly, I don't know if I'd say it was good. It, like, research has suggested that it could like leach into the water over time. So I think it's kind of like we're not seeing immediate flushes because it's going into the soil, but I would think over time it would eventually get into the water anyways, whether it be surface water or groundwater. Yeah.
Which is what you said. Thank you, that's helpful.
It's so relevant to that question. I seem to recall you have some data showing the changes in the chloride concentrations over time, which would be relevant to that. So if it's retained by the soil, what would you expect over time?
It accumulates and doesn't leave the system, it just accumulates in the soil.
And it might build up over time, particularly with storm events, right? There's a long-term increase.
Yeah, approximately.
What was your favorite part of the field trip?
I love the field work personally. It's a good place to be in the summer. Yeah. I like the lab work where we can be in the air conditioning.
I talked about Lake Sunapee doing shoreline buffering. And since you tested mostly along the tributaries, do we know, quantify how the shoreline areas affect? Phosphorus exposed to the tributaries and there's a point for shoreline buffers, is that how?
Right, so that's definitely one of the limitations of our study is that all of the samples that we collected were in tributaries and they were behind where the homes along the shoreline are. So we can't quantify the impact of the homes on the shoreline, unfortunately, because I would think those homes on the shoreline would have impact because they're right there. But just kind of like shoreline buffers and everything, if you own shoreline property, is important, and just stopping water from going directly into the lake. Yeah.
I know on Lake Sunapee, they tend to try to engage landscapers to get involved and to try to work with them to try to figure out if they're going to people's houses and landscaping and doing certain things, that they would implement some sort of protocol that would not affect water, lawns, lakes, whatever it's going to be. does Pleasant Lake do anything like that? I mean, I'm not sure, most people probably don't fertilize around the lake, but I don't know that to be true, so. Do you know if there's any protocol with that, Nick? Anything?
I don't know. I think the PLPA might, I'm not aware of it. I think a lot of those landscapers on Big Lake Sunapee are probably landscapers on Pleasant Lake and Little Lake Sunapee as well, but the Lake Sunapee Association has had workshops for landscapers in the past. It may be something that the PLPA would like to consider doing as well for, local landscapers. It's a nice opportunity to engage with those folks and talk about best practices.
Right.
The LSPA also has their Watershed Wise program, where they have someone come out to your property and you get, they see if it's watershed friendly, with your landscaping and vegetation and everything in there. I know they're trying to make that more available to more people, so that would be a good thing to look into if you're interested.
And the New Hampshire Lake Association has the same practice where they will come to individual homes and actually give you feedback on just best practices. So there's scorecard. Basically, they'll let you know what could be improved, things that you're doing well.
It's awesome, by the way.
Yeah.
And I think that this isn't my statement, but the amount of the billions of dollars in real estate and investment around the lakes, by ruining a lake, ruins a lot of investment too, so.
Yeah, I was just gonna say, in terms of Pleasant Lake, and I've only lived here about 6 years, but there are much bigger homes now around the lake. And a lot more pavement. And many of the homes are right on the road. And then there's a steep drop off from the road right into the lake. So I think that, in terms of runoff, that's just increasing. And in June, we have the water warming, we have more boating activity, all the seasonal people are here. So all those things, all that increasing human activity as well as what you're talking about, the role of chloride and phosphorus, it's almost like a perfect storm there.
So, was any study or any samples, I should say, taken from the low plain pond area or that side of Route 11? To see what the difference between that phosphorus is versus the Bunker Road and or the pond at the Elkins end of the lake?
Yeah, that was our headwaters. So we took a sample at the Esther Courier Wildlife area and then low plains as well, and that served as 26 and 27, which did have lower concentrations compared to the tributary samples. Yeah.
I don't know this around when in the winter when they're doing lakeside bunker, what's the practice in the DPW? Are they? I know what they do in front of my house. I know that. So are they doing salt, sand? What are they doing?
Primarily sand.
Primarily.
Yeah. So during our class, during the school year, another member of our class met with the town department and asked about their salting practices, and they said that they only salt the turns, the sharp turns around the lake, and then also Pleasant Street because it's so steep, but they mainly use sand.
Good, thank you. Do you think the easing of the Shoreline Protection Act is just adding to the issues? We had bought a house in 2008, and that was right when it was enacted, and we had to put a rain garden in at the end of the driveway, and it was, we were limited to the amount of impervious surface, and I know a lot of these requirements have been lessened since then. So,
Right.
have you heard anything on that, or not really?
It's not something we explored, but I definitely imagine that it would impact with newer homes being built.
Yeah, it definitely doesn't seem like a good thing that those things have reduced in recent years. But yeah, we didn't look into that.
I got a question about cyanobacteria. It seems like the blooms happen about the same time that the pollen's coming out of the pine trees. Is there any relationship there?
So I'm not exactly sure. That would definitely be an interesting thing to research. But at least when I worked at the Department of Environmental Services in the cyanobacteria program, my supervisor noticed that like blooms would also come like right after the pollen came into the water, and she thought that it was like a kind of a shot of nutrients into the water, but I'm not sure if that's, I'm not sure of the science of that.
Sounds like a topic for further research then.
Will we be getting the raw data? I know Craig's anxious to go through it all.
For sure. Maybe we did. I don't know if we sent it to you, but we can definitely send it to you as well. I believe we have like, I don't know, over 1,000 rows in that data set, so it's a lot to look through.
What's your guys' favorite site?
Not 26. That one's pretty gross.
Wait, I actually have one.
I think Great Brook. It's very refreshing.
Yeah. I think I like the outlet actually, just because it's so fun.
Could you describe each of you the skills and value that you learned from this 3-month experiment? I mean, the things that if you were to sit and take a second and reflect upon what you learned about the process of science, doing a project, experimental sampling, and how that transformed, if it did, could you reflect on that? Do you have anything to say? Yeah.
It definitely challenged me a lot with scientific process and answering questions. I feel like before this, I did not have a lot of experience, like the full process of collecting samples and learning things like R and yeah.
So just to be clear, neither of you had touched R a little over a year ago, correct?
Correct.
And everything you just saw graphically was all done in R?
Yes.
Just clarifying.
I think I realized that there's a lot of management that goes into a project like this. And definitely getting into the summer, we had 7 less teammates, less assistance from our advisors, even though they were still there and helped us when we needed it and were amazing. But there's just a lot of steps and pieces in this project, and kind of just working through everyone and to keep it going. And yeah, it was a great experience.
Many thank you very
Well, we certainly would like to thank you all. These collaborations, Dave and I work on these community-based research projects every year. We try to find interested community members who have some environmental challenge that students can get their heads around and start trying to work on a solution. And these aren't easy questions to answer. They're messy. As you can hear here, we don't have a definitive smoking gun, but we certainly learned a lot about your watershed. To Craig's point, they know more than probably most people who have ever analyzed your watershed. 1,000 different samples, the 1,000 of hours of people hours that have gone into collecting, compiling a very good database that can be used for future research or go as the foundation for a watershed management plan, if that's something you want to pursue with the state. These foundational background data sets are really instrumental in helping move the dial to try to answer some of these questions. And I'm very proud of the group. Dave is very proud of the group. They really, this project, students really embraced the process wholeheartedly. And you know, for Quinn and Sam and Stephen to keep to do what they did in the summer, it's a tremendous amount of effort and I'll remind you, undergraduates. These are not graduate students, these aren't postdocs. These are students who are learning the wet chemistry analysis, the field sampling analysis, the data management, and that R they keep talking about is the statistical analysis, doing, you know, strong statistical analysis on data. And it's a big skill set to learn in 1 year. And so, I mean, I think the students have come a long way, and we're very happy to have worked with you all, and thank you for your support for the summer. And these are incredibly valuable projects for students' growth. And we hope it was, you know, useful for you as well. And
Incredibly valuable in terms of the data, the foundation it provides for managing the lake. Because really, the people around the lake are the lake managers effectively. And, you know, what's going on and where is it going on? And here we have some really, really good information on that. So you guys are the ones to thank.
Well, you all ask great questions, and those are, I mean, you know, Dave and I, oh, it's a great question, because these are good questions we don't have a strong answer to, but more research would be great. And I think, you know, Bailey Tremblay was mentioned several times, looking at the sediment, and Craig has talked about quite a bit, you know, the importance of the sediment and what phosphorus bound is in there, and is it bound well, or is it something that can move and become labile in your lake, is an important question to understand. And I think that is a next big step really to move forward. And some of the tributary work, you know, I think is really important as well. So
Bailey's gonna present her Scholars Day. So April 22nd is Scholars Day here. The entire day is senior capstones. And Bailey will be presenting the sediment work then too, so if that's something that you're very interested in. I don't think the times are set for when they are presenting, but it's in this room during the day generally.
Will there be sediment phosphorus data?
Yes, that's what she's
phosphorus,
Oh, excellent.
labile non and aluminum ion ratios she's doing for that.
And she's looking at several lakes around the region.
That's even better.
Yeah.
That's even better.
Yeah.
Something that Nick and I always talk about when we work with students is we get them right where we want them, and then they graduate, and it's like, no. Oh, that worked. And so I can't tell you how pleased it makes me, and Nick, I hope I speak for him too, to be able to have the opportunity to have students really going like this and keep the trajectory through the summer, because it does for both of them keep them going. I'm seeing it because I work with them on their capstone projects, teaching one of the classes. Nick sees it in his work with Quinn. I see that it continues on and it keeps pushing them more, so their growth, instead of in the summer dipping, it really pushes them into another level without the donation. That is not possible. So you made a really big difference in their lives. It's really meaningful. So thank you on behalf of Nick and I.
And we benefit. The community benefits because you guys have trained the students all year long at no cost.
Well, I hear some.
Well, no financial cost. You're right. I am familiar with this.
So you collected 6 or 7 sediment cores, is that right?
Yeah.
Are those going to be examined by the young lady?
Yeah.
They will be.
So,
That's the plan.
yeah, April 22nd, she has to present that material.
Yeah, I know you said from the lakes around.
But also,
And so I think it's this Sunday, she's going to, so the sediment cores that we collected with Doug, right? We went out and had a great time going and trying to collect near tributary core samples.
Right.
As Quinn will attest to, the challenge is that's not very soft sediment at those inputs. There was one that was pretty decent, the others, so we've got some sediments, and we certainly can analyze that. Bailey's question and real focus is looking at the deep site sediments, which gives you much more informative information about that phosphorus bound, the iron and aluminum bound, like that is a very important piece of data for you. So I think on Sunday, I believe, you're going, out on the ice and doing a deep site sediment core, at least deep enough that you're getting some sediment. That would be the one I think Bailey's gonna present on. The other samples, she's got a whole suite of samples, so it depends on how much time she has to do, but I think the deep site is the one that you really are gonna be more, that would be the one I would focus on if she's limited on time.
Well, I think one that I am focused on, and I think we are focused on, would be what you call the Fire Pond Inlet, Chandler Brook. Because of the boats moored there.
Yeah, I will say that.
Physical upset of the sediment that could cause the legacy phosphorus to be a problem there.
Yeah, the sediment core there was not particularly deep. It's a hard packed sediment. And so what's happening, there's a fair amount of flow, right? When you have so all those fines are going out into the lake deeper and settling in deeper spots, right? So that very entrance point, it may be one that's interesting. I think what we really want to capture, if I'm thinking about the water chemistry, is where we're seeing low oxygen potential and sediments. That is the phosphorus that is going to want to leave the bound sediments and go into the water. And so it's a good question. And I think it really depends on how much time she's gonna have, and if that extra sample she can run, I think she'll run it. But John, it's a good question. We don't know, right? And so these are all good things to answer. The chemistry,
It's a critical area for us.
yeah, the chemistry suggests those deeper, I mean, Craig can speak to this too, but those deeper sediment spots where you potentially have low oxygen. It's a critical water chemistry piece.
It's absolutely true, but the other thing that can happen is there can be sediment resuspension.
Sure.
During storm events.
Sure.
That can bring that up into the phosphorus up into the surface water. And it's likely it will some of it will stay bound, but some of it will not be bound, whether it's broken down by sunlight or other things. So I think it is certainly relevant to know, I mean, how much do we want to spend, right? To collect the data that we need to answer these questions.
Yeah, along those lines, what about sampling the sediment on the bottom of the fire pond?
Yeah, that's what we're talking about.
Sure. There's lots of great questions, right?
Yeah.
And it's time and people, you know, and resources. So it's a great question.
You have more students?
Always.
That's the beautiful thing about college.
I think that leads to another question though, because I know some of the work that was done here kind of leads really well into submissions to the states and looking at watershed and management plans and that sort of stuff. But there's also a lot of like next questions that this, I mean, as you think about your future students and the kinds of projects that could be uncovered, are there natural like next projects that would be worth, you know, trying to circle some resources around?
What was it? How much time? Dave says, how much time do I have? There are questions, right? And you know, the other part of the story, right, is that we've tried very hard as an institution to pick projects for different stakeholders all the time, so that we're working with multiple community members and getting students exposure to different opportunities. So for senior capstone projects, I think there's a lot of questions we can pursue. I think for a third year project, for instance, we like to pick a lake association here, another, so the college has opportunities across different areas, right? I think certainly for student projects, there are many questions that could be asked. And we try to identify students who get jazzed about water chemistry. Dave and I get excited about it and start, you know, moving them in certain projects that we know we already have a database and we can dive deeper into. So there are opportunities, absolutely.
I do like one nice thing about students, especially when they're there in the summer, their capacity to sample at times that are inconvenient for many other people is very valuable. It's really, really hard to sample a lot often, but that's kind of what you need. One of the funny things about one of the slides there was that on June 20th or whatever it was, I was driving on 89 home to Norwich and got nailed by that storm. And I texted them and I was like, get your
Example, Huron.
In fact, I think I still owe them a dinner for that. But it was so tumultuous, they couldn't get the discharge reading because the lighting was so bad, right? So it's like having students to be able to do those things in those bad circumstances is really interesting. It seems that these resuspension events are really important and they're infrequent. So just being like, okay, you're gonna go out when there's a lot of boat activity, when there's lots of storm activity, and just knock them out throughout the term. Like that would be a nice one, I think. You have to find a really rugged kind of a student to do that.
Dave, your comment about owing dinner is a good segue into, I think there are a lot of people here that are wanting to get to dinner. But
Yes.
I think if anyone has more questions, please come forward. I think we're all more than happy to stay and talk, but somebody needed to bring some closure. But thank you very much, everyone. Yeah, thank you. Place the dining hall over.
30.
Oh, sure. Good. Hi, Tylee. How are you?
Did I hear you were I worked there for 20 years.
Oh, great. Thank you. Good. Were you having technical difficulties?
Gosh, yeah, the clicker, and I like do so many slide changes because I think they're fun, but it was like my worst nightmare. You handled it. Thank you. Yeah, it's like they're beyond.
I know this guy. So what's graduation? Because I love it.
Yes, May 10th.
We've got a board meeting.
Yeah, I looked at it.
Yeah, we're gonna figure out where they want it from, so I'm just gonna leave it.
And that's what we.
And then we should not that far get it back before that final. In case that's like in a quick place here and send it to you.
Okay.
Yeah, that's part
Great
right.
thoughts from tonight. Yeah.
We made interesting places.
For a while, it's way outside the school.
I know.
You did it well.
Yeah, so that's good. Yeah, but it's something that.
Thanks again.
Yeah, thank you.
You got the dining hall.
Oh, yeah, right.
My new favorite spot.
Yeah.
And it's true, you can't figure out whether it's gonna be with your dog. What you might think about, but maybe not right now, is that there is a different called mental pocket that so, and those are human beings. They're a human influenza bacteria, enteric bacteria. And so you can then determine if it's from. It won't grow. You can. So it's something you might want to check into. I happen to know it because that's what we used to do. When we did our sampling with my dad, who was predecessor. My dad was the health officer. And he taught microbiology here at Colby. And so we did all, and he did his master's thesis at UNH.
So you did that testing back then?
We did that testing back then.
And they tested it at UNH?
No, we did it right in our labs down by the lake. So the process out
across from our house. He had his lab at the end of it, he had a little portable.
Whether that's actually there.
Filter, so we 100 mils through, and then take him under the filter and put it on. And peaky bit, so they would then auger, we would pour our own, and it was a raised auger filter, so you just put the categories on it, and incubate it for, 24 hours. 40 hours.
Wow, that's interesting. Yeah, well, definitely.
But it's something that you could, if it's something like on a fall.
Yeah.
It's like, oh, I wish we'd known that earlier, but it is another way to delineate or differentiate between human and animal.
Yeah.
quality.
Yeah. Yeah, because I just recently learned about like the caffeine studies or
Yeah, that's
artificial sweeteners
interesting,
or
yeah.
like artificial food coloring.
As a tracer?
Yeah,
something?
yeah. So like testing for those to see what the, like if there is.
Putting in like fluorescent green dye, but that's if you suspect something's failing. Yeah, put it in one end and then wait for it to flush out. Yeah, but again, you have to have a target,
Yeah.
because I mean, you're looking at non-point scores. I mean, that's.
Yeah, yeah.
And then, you don't even want to talk about the erosion of the water, boats going by, and the white boats with the big waves, and, it's too many different scores.
Right, so many variables.
Yeah.
to track of.
I mean, okay, well, actually, not the rain on our watershed, but.
Right? If we could just stop the rain, everything would be fine.
We've got the rain, so you can't really do that.
Right.
But anyways, great job, guys.
Thank
So-
Yeah.
It's fun. Yeah, get down above that part, so now it's fun. It's very fortunate that I live on the lake.
Thank you again.
And a lot of people. Favorite lake. Yeah, no, I have to order a
But they haven't.
model that they approved at our last board meeting. Now I can order it because we're concerned about the spiny water fleas, because they will attach to fishing line and lines on the sampler. So if, let's say somebody hasn't treated it right, they could then, we could use it once a month and possibly transport spiny water fleas into our lake, so we're gonna buy our own.
Yeah.
But then all I need is sample bottles and I won't need any other stuff.
Accessible.
Anyways, good luck. So you both planning to go on to get masters or work, or what are you thinking about doing?
About 4 years good enough for now. Start working.
That's what I did. That's what
Yeah,
I did.
same here,
Yeah.
so, but I'm like looking into internships and jobs at the state, so I definitely wanna keep working in drinking water.
Yeah, well, it's kind of cool.
Yeah, like water.
Unfortunately, they didn't have environmental science.
You are curious.
That's why I got into micro, because I wanted to be an environmentalist. They put me into civil engineering. It's like,
Oh, yeah.
no, it's like, I went the other way.
Yeah.
Anyway, good luck.
Thank you.
Take care.
Yeah, ask them. I don't know. Yeah, they might know. Yeah.
Oh my gosh.
pH ranges.
That's screen sharing. I know, well, I was thinking, because we want to stop recording it. Yeah, you stop recording.
They were just.
That's not right. All sorts of levels.
Yeah.
Nothing.